Hi, so let me show you some visualization techniques for plotting 3D pictures in Paraview. And here inside the folder result we collected some files. There's a PVD file and there's a bunch of VTK files with the extension VTU, and all the data, visualization, all the solutions are kept inside these files. But the PVD files, it's a text file which contains the list of all these output files. Okay, if you want to generate some movies or some animation, it's better to open the PVD file directly. So I open this and we go with here, then you should apply and you will see something like the solution in this form. So of course I changed the color map in my case. Maybe you can put it on the side or in this side, it doesn't matter. And so here is the solution. We don't see anything what is changing inside because the boundary condition is 0 and on the boundary we have it 0. So one way is to cut it. One of the ways to visualize and see what is happening inside the boundary, you have to clip it. So here we see that there is some plane, and when you apply, so you will see that there is something happening inside. So this is a partition of the part of the initial condition, which was a torus. So here we see the clip. This plane is parallel to the y-axis. So when we do parallel to the x-axis, so we will see probably something like this solution. Okay, and in the z-axis we will see something like that. So this is something initial condition that we set it up. And so if we want to see the 3D view of the initial condition, we come back here to the temperature, and there is something called threshold. It's a function in Paraview. So you choose, and there's a minimum of your solution is plotted is 0, and maximum of the solution. In my case, I put rho equals to 20. So if I put here it's like 1, then it says that extract only all part of the domain with the solution bigger than 1 and less than 20. So when we apply, we will see that let's disable that part. So this is the initial condition, like a torus that we set it up. So if you want to save it, then you could probably want to save it the boundary as well. So we click it to the temperature, and we come, instead of surface, you choose wireframe. So it's going to be the boundary which is surrounded this torus. Of course, you can go file, save a screenshot. Maybe we can choose it like initial. So the extension is PVD, and you save it. So if you want to change the background, here it is gray. So you go all the way to the bottom. There is a color. You choose probably white, and you see that this is probably good color to choose when you want to save it and put it in your report. So let me for a while to just restore the default, because I want to show some other functions in Paraview that might be useful. So okay, so here we had we cut it up, and so this was initial condition. When we move in time, you see that the solution changes, it gets more dissolved. So when it hits the boundary, it is 0, so it means that the concentration is just diffusing out from the boundary, so etc. So in the final time, I think it's very small. So you see the magnitude of the temperature is quite small. Alright, so if I want to plot the solution over some line, so I assume that I put some line over here, maybe parallel to x or y axis, then I want to plot what is changing along the line. You could go to temperature, to the original file, then you go to filter, alphabetic, and here is plot over line. So you see that this is a line that it is plotting, and I think as it's like a diagonal line in this case. So when I plot, maybe we should come back to the beginning. We see something like that. So it is not obvious what is it plotting. Therefore we go here to this plot, to this line, and we take it parallel to x-axis. So when we put parallel to x-axis, we will see that in the x-axis there is a change in your solution in this form. So if we plot it probably parallel to the z-axis, there will be nothing because the line is going on from the 0 part. So in any case, you see that this is your solution. Initial condition, there's a it's a 1D plot. When it changes in time, here you see also the magnitude of the solution is dropping, and on the right you could also see that it is eventually disappearing, so diffusing out, and eventually at the final time everything goes to 0. Okay, so here you see that it's all dark blue. Maybe you can also change it, rescale it here to get the right scale according to your solution. So let me close this 1D plot, and we are back to this 3D plot. Then if you want to put another color map, you can go here and choose from the list some other selections. Maybe something like that, from cold to warm. So this is also could be one possible choice. Yeah, so I hope it was useful, and if you have any question, you just let me know.